Hi everyone, so this is lesson 2.6, Simplifying Algebraic Expressions, and this is the last lesson for this unit. So by the end of the lesson, you should be able to apply all the knowledge that we've done throughout this unit to simplify an algebraic expression, and we should be able to relate them to other like geometric problems, so like our word problems that we've been doing with like area and perimeter and volume. So we're going to start with some practice questions first. Hopefully we've gotten the hang of this by now, and some of these seem pretty easy. We're also going to cover a few more challenging ones. So, oops, forgot to make this smaller. Alright, so here we just have a simple distribute question, distributive property, so x times x, x squared, and x times -5 is -5x. Done. So again, this is just simple distributing. -2y times 3y, -6y squared, -2y times 1, -2y. Again, distributing, but with some bigger exponents. So -3n to the 5 times 3n. So negative times positive is a negative. 3 times 3, 9. N. And then exponent rules, add your exponents. 5 plus 1 is 6. -3n to the 5 times 1 is just -3n to the 5. And then -3n to the 5 times -2n squared. So negative and a negative is a positive. 3 times 2 is 6. And n, exponent rule, 5 plus 2 is 7. Okay, this one should be rewritten in the proper order. So 6n to the 7 minus 9n 6 minus 3n to the 5. So look out for little things like that. For D here, so again, this is just some distributing. We've got a couple of sets of brackets. So 2 times 3x is 6x, and 2 times 1 is 2. 3 times x is 3x, and 3 times -4 is -12. Collect your like terms. So we've got x's and we've got constants. 6 plus 3x is 9x, and 2 minus 12 is -10. Okay, and then again, we're distributing lots here. So 4x times 3x squared, so 4 times 3 is 12, x, 1 plus 2 is 3. 4 times -2 is 8, and then x times x, x squared. 4x plus 1 is 4x. Or, sorry, 4x times 1. Over here, -3x times 2x squared, so -3 times 2 is 6. X, 1 plus 2 is 3. -3x times -5, negative and a negative is a positive. 3 times 5 is 15, and then x. Okay, so collect our like terms. So we've got x cubes. We're going to do those first. So 12x cubed and -6x cubed. And then an x squared, we have one of them. And then we've got some x's. So plus 4x plus 15x. Alright, so now let's do the like terms. So 12 minus 6 is 6x cubed. And there's only one 8x squared, so we just leave it. And then we've got 4x plus 15 is 19x. Okay, and it's in the correct order. Alright, let's keep going to some harder ones here. So here, still distributing. Oh, this one's an easy one again. Okay, so 3x times 4x, 12x squared, 3x, oh, maybe a little bit more challenging. 3x times -5x, so -15xy. Right, no rules for this one with exponents, so they're not similar bases. Then 2xy, or 2x times -2y times 2x is -4xy. Make sure you write in alphabetical order. And then -2y times -3y is a -6y squared. This one, the like terms are already collected. It's just those xy's. So we can leave the 12x squared. And then we've got -19xy, right? -15 minus 4. And then the 6y squared stays at the end. All right, so this one, be careful, order of operations. You cannot subtract these two first. Definitely not. This 3x is attached by multiplication here, and we have to do what's in the brackets first anyway, so that's our bedmass. So we're going to leave this 2x minus 3x in a bracket. And then we're going to simplify inside our brackets here. So we've got 5, and then we're distributing just a negative 1 here. So minus 2x plus 1. Okay, so again, you still cannot subtract this 2x and 3x, even though they're like terms. This 3x is attached to this bracket by multiplication, and we know we have to multiply first. So in this case, we're distributing first. So the 2x stays, and then we distribute this negative 3x. So negative 3x times 5 is negative 15x. Negative 3x times negative 2x is a positive 6x squared. And negative 3x times 1 is just negative 3x. So now we can get our like terms. So there's only one x squared, so we're going to leave that first. And then we have a lot of x's. So plus 2x minus 15x minus 3x. So we're going to leave this 6x squared, and then we're going to figure out what all these x's are. So 2 minus 15 is negative 13, minus another 3 is negative 16x. Okay, so last two. Yes, fractions did not go away. So we can still do these ones with fractions, so please make sure you still know how to do add, subtract, multiply, and divide with fractions, because it works the same with these. So if I look at this one, I'm just looking for like terms. So there is no distributing, there's no multiplying, no dividing. All these fractions are in simplest form, so we would look for like terms. So we've got some x squareds here, so we've got 1/2 x squared, and then we've got plus 1/4 x squared. And then the y's, so minus 3y minus 1/3 y. So yes, we can add these because we know how to make a common denominator with our fractions. So we've got 1/2 and 1/4. So lowest common denominator would be 4. So this first fraction we had to multiply both by 2. So this would become a 2x squared. And we didn't have to do anything to the second x squared fraction, so this is just going to be plus an x squared. Okay. I'm just going to put a plus sign in between and then a bracket so that I don't have to worry about dealing with these minus signs until later. So again, I need a common denominator for my y's, so it would just, the lowest common denominator would be 3. So this one, it's like saying 3 over 1. So we had to multiply by 3, so this is a negative 9y. And then this one we didn't touch, so just minus y. Okay, just like before, simplify your top, leave your bottom. So this is 2x squared plus an x squared. So we've got 3 over 4x squared. And then over here, we've got a negative 9y minus another y. So this is going to be minus 10 over 3y. And then that's as simplified as we can get. So watch out for those fraction questions. Make sure you're still using all of your fraction rules. All right, and then last one here. So we want to try to simplify this. Brackets first. We could distribute here if we want first, and then we could also deal with this one. So here we've got 5x cubed plus 30x squared minus 2. And then inside their brackets we've got x minus, and then distribute. 2 times 1 is 2, and negative 2 times 2x squared is 4x squared. Okay, so then copy these ones out. And then we're going to distribute in here. We can't simplify in that bracket, so we're just going to distribute. So we've got negative 2x plus 4 plus 8x squared. So now, like terms, we have no other x cubed, so that stays at the front. We've got some x squareds, and then an x and a constant. Add up these like terms, so plus 38x squared, and then leave the rest. So let's try some of these geometric ones. So we want to find the perimeter of this one. So we know, again, perimeter for triangles is just side 1 plus side 2 plus side 3. So we just have to add these up. So 9x minus 10 plus 2x squared plus x squared plus 4. So these are all just nice, easy adding ones. So we can just get rid of our brackets, collect our like terms. So x squareds go first, x's second, and then constants last. Plus 9x and minus 6. Okay, it's a word problem, so therefore perimeter is 3x squared plus 9x minus 6. Okay, so we're just going to try a couple more of these ones. So we've done one like this before where we're finding missing side length. So again, this is going to be like our missing side equals our perimeter minus side 1 minus side 2. So we've got our perimeter is 13x plus 11 minus side 1. I'm just going to use that one as side 1, and then minus side 2. So we need to get rid of our brackets first. Remember, if it's minus, it's like distributing a -1 now that we know what distributive property is. So distribute your -1 or just switch your signs. And then collect our like terms. Okay. And then simplify those like terms. So 13 minus 3 is 10, minus 6 is 4x, and then 11 plus 2 is 13, plus 6 is 19. And then word problem, therefore, the missing side length is 4x plus 19. Did I give something up? Oh no, I made a mistake. I just saw it. This is 6x plus 6, and I wrote minus. Uh-oh. So we're going to have to go back and change. So this should be a minus 6. This should be minus 6. And this is going to affect my final answer here. So this 19 isn't going to be right. So now I've got 11 plus 2 is 13, minus 6 is 7. There we go. Again, check our answers. Okay. So then this one, we want to find the area of the shaded region. So if you don't remember doing these from grade school, the easiest way to do them is to find the total area for this entire object. So like if it was all filled in using, right, this length times this width. Then we could find the area of this inside region. So like this length, I'll call length 1 times this width. And then we could subtract them. Okay, because then that will just give us what's left over. So I'm going to call it area, oops, that's a bad A, area total, or T, for my whole outside area. So that's length times width. So we're just going to call it 11x plus 20 times that 6x squared. So distribute here. So we've got 66x cubed plus 6 times 20 is 120 x squared. Okay. Then I want to find my area, and I'm just going to call it of I, like inside the inner area here. And again, so I'm just going to call it, this is length 1 times width 1. So length 1 was 10x squared minus 3x, and width 1 was 8. So distribute here. So we've got 80x squared minus 24x. So now my area of the shaded part is going to be my area total minus my area of that inside one. So my area total, right, we found to be this, minus the area of the inside. So get rid of my brackets. Distribute my -1 into this one. My like terms are actually already collected, which is nice because we have cubed and then squareds and then just x's. So then we can just simplify here. So 40x squared plus 24x. And then therefore area of the shaded region is 66x squared plus, oops, not squared, cubed. I wrote the wrong number. Cubed plus 40x squared plus 24x. Okay. All right, and then the last one here. Okay, so the area of a square, this is important. Area of a square, we know that all sides are the same. So they told us what the area is, and they want to know what the side lengths are. So area of a square, if we think about it, right, if we call this the length, all of them are the length, right? There is no real width because the length and the width are the same, right? This is normally the width, but it equals the length. So instead of writing area equals length times width, I could just write area equals length times the length, which is the same thing as saying the length squared. So if I were to sub in what I know, right, I know what the area is. So the area is 16x to the 6y squared, and that equals this length squared. So the question here is, what's the opposite of squared? Well, the opposite of squared is square root. Opposite of squared is the square root, and I think that we've talked about this before. So what we want to do is take the square root of both sides of this. So we want to square root both sides here. So on this side, the square root, right, is just going to end up with length because it gets rid of the squared. The square root of 16, well, what times what is 16? The same numbers. So 4 times 4 is 16. And then for our x, we're just going to divide them by 2 is the way that it works. So 6 divided by 2 is 3, and 2 divided by 2 is 1 for the y. So the other thing we have to remember is that when we write our answer, we should have a plus or minus 4 because we talked about it before that something like -5 squared. Oops, my pen decided to disappear again. Oh, great. I don't know why. Bear with me for a moment, please. And so my pen decides to work. Oh boy. Doesn't want to work. We're so close to the end. Come on, pen. No? It just doesn't want to work at all, eh? Okay, well, I can just explain the rest. Remember that if we did something like -5 times -5, that gives us a positive 25. So that anytime we have a square root, we have to make sure that we're writing it with the positive or negative, because technically that 4 could have been a -4 times a -4, or it could have been a positive 4 times a positive 4. The other thing that we should be writing here is our therefore statement. So we could write, therefore, the side length of the square is, and again, here we would know that's positive because lengths can't be negative, so it would be the positive 4x cubed y. Okay, so sorry my pen decided to stop working. I'm not really sure why, but that's the end of the lesson anyways. Good thing. So please try your homework and check your answers.